Okay, I'm going to talk about distance and displacement. Distance is pretty easy. You already know distance. I walked 4 miles to work today. I walked since lunch. I have gone 350 meters because we use meters in physics. That's distance. How far? How far you traveled? How far is just basically distance. Displacement is how far away in a straight line. In a straight line, and what direction. Okay, so distance is a scalar. Distance is a scalar because it has a magnitude, a size. 4 miles, 350 meters. It doesn't have a direction. Displacement has a magnitude. Because it's a vector, it has a direction. So it has magnitude and direction. Magnitude, again, is just how much in proper units, and direction. And that's important. Okay? Sometimes you don't see the direction. Sometimes if we declared what direction is positive, we just say 3 meters or -2 meters. Negative would be the direction. The fact that the 3 meters is positive, that would be the direction. But we could have 3 meters up, down, left, right, northwest, south, things like that. So this displacement, the way you'd specify it, yeah, let's just say instead of 350 meters, I walked, since lunch, I walked down here, I went over to that room, I came back over here. I had a really funny path of 350 meters. But interestingly, just before lunch and just after lunch, I was here. So my displacement from the beginning to the end ended up being 0 meters. So the distance and the displacement can be two very, very different things for the same trip, for the same path. Okay, let's get a little more specific how we differentiate between the two of those. Okay, distance and displacement. So I just gave a big roundabout way. Let's say I walk 5 meters north and then 2 meters south. In this case, north will be up on the board. Okay, so total distance 5 plus 2 is 7 meters. Okay, not hard at all. The displacement, and we're going to see a different notation later. The displacement is how far away you are from where you started. So I started here and I ended up here. I started here and I ended up there. And you can see 3 plus 2 is 5. I went 5, came back 2. This is 3 meters, but really it's 3 meters north. Okay. To avoid having to write north, south, east, west, up, down, whatever, sometimes what we do is we declare a frame of reference. So in this case, what I could have said is, I'm going to call north positive. Okay, and I want to write that arrow, calling that positive. And then I could say I had a displacement of 5 plus 5 meters, and then a displacement of -2 meters, and that ends up being plus 3 meters. Then I don't need the north there. It just ended up 3 meters. If down was positive, that would be -5 plus 2, that would be -3, but I'd have to write that as -3 meters. Okay, again, if this had been turned around. So that's distance and displacement. You're really just saying, how far away am I at the end from where I started? If you were giving somebody directions to get that same end point, right? You say 3 meters, you have to tell them, I want you to move 3 meters north from the beginning of the trip to the end of the trip. Okay? 3 meters is not enough of a specification without saying 3 meters north, or again, since we had a positive sign there, plus 3 meters. So you're always thinking about how to specify how to get that person from point A to point B. And that's the difference between distance and displacement. Now, when we do it in one dimension, very frequently, an awful lot of the work we do in physics, we're talking about people moving, car moving along a straight line, something like that. When we talk about one dimension, it's typical that we'll declare a positive direction. Maybe it's east, south, forward, backward, something like that. And then the displacement we write as delta x. That means change in, that delta means change in x, change in my horizontal position. If we talk about a vertical position, I dropped the pen, then I might want to declare down as positive, and then I would want to say this is delta y, what my displacement is. A positive delta y would mean it went down, negative delta y, the way I defined it, would mean it went up. So that's the difference between distance and displacement. Distance, how far you travel and all. Displacement, how far away you end up from where you start and what direction you ended up in.